Just in case you're having trouble doing the calculations involved with this experiment, I thought I'd show you how my calculations went. When I did this experiment, the mass of my graduated cylinder was 111 grams. The mass of the graduated cylinder plus 50.0 milliliters of vinegar was 155 grams. With the scale that I used, I could only read grams out to the ones place, so that's why I reported my answer to the ones place. The volume of clear ammonia that I used in the titration, just like the book said, is 10.0 milliliters. Remember, we can read the graduated cylinder to tenths place, so I can report my measurements of the graduated cylinder to tenths place. And finally, when I got done, the end point was reached when I added 12.5 milliliters of vinegar. Once again, graduated cylinders can be read to the tenths place, so I can report my volume to the tenths place. Well, that's all my data. Now let's do the calculations. The first thing the book tells you to do is get the density of vinegar. Well, that's not so bad. We know the mass of vinegar. If I take the mass of the graduated cylinder plus the vinegar and subtract out the mass of the graduated cylinder by itself, the only thing left is the mass of vinegar. So 155 grams minus 111 grams is 44 grams. We're subtracting here, so we have to deal with the rule of subtraction when we're dealing with significant figures. And so since both of my measurements go to the ones place, my answer goes to the ones place. Now to get density then, I just divide by the volume, which was 50.0 milliliters. I can only have two significant figures because 44 has only two significant figures. Alright, so that's the density of vinegar. Now to get the mass of vinegar, I just take the density I figured out and multiply by the volume that I added. I added 12.5 milliliters of vinegar to get to the end point. If I multiply by a density of 0.88, I end up finding out that milliliters cancel, and I'm left with 11 grams. Alright, now I use vinegar as a source of acetic acid. But vinegar isn't 100% acetic acid. In fact, it's only 5% acetic acid. So I need to figure out the mass of acetic acid I added. Since it's 5.00% acetic acid, I take the mass of vinegar and multiply by 0.0500. I can only have two significant figures because 11 has only two significant figures. So in the end, the mass of acetic acid that I added was 0.55. Alright, from that I can get the moles of acetic acid. The mass of a single acetic acid molecule I can figure out from the chemical formula. Chemical formula is given in the book, and when you figure out the mass of the acetic acid molecule, you'll find that it's 60.0 AMUs. Now remember what that tells you. That tells you that 1 mole of acetic acid is 60.0 grams of acetic acid. That's my conversion relationship between grams and moles. Now I can figure out the moles of acetic acid that I added. I take the mass and multiply by the conversion relationship. I put grams on the bottom so that they will cancel, and I find out that I added 0.0092 moles of acetic acid. Well, that's the number I needed. Why? Well, we're doing a titration. Remember, in a titration, we take acid and add it drop by drop to base, or vice versa. And when we reach the end point, we know we've added just enough acid to react with all of the base that's in the sample. Alright, now if we look in the book, we see the chemical equation between acetic acid and ammonia. And we find that they react in a 1-to-1 mole ratio. If I add 5 moles of acetic acid, 5 moles of ammonia react. If I add 0.0092 moles of acetic acid, then 0.0092 moles of ammonia react. Well, the endpoint was reached, so that means that's all the ammonia that's in the sample. So the moles of ammonia in a 10.0 milliliter sample are 0.0092. Alright, now calculating the concentration, or molarity, of the ammonia is a snap. Molarity is calculated by taking the number of moles and dividing by the number of liters. We know the number of moles, 0.0092. We also know the number of liters. The volume of the clear ammonia was 10.0 milliliters. When I convert to liters, I find that that's 0.0100 liters. So moles divided by liters gives me a molarity of 0.92. There are two significant figures in the number of moles, 3 in the number of liters, so my answer can have only two significant figures, and my ammonia had a concentration of 0.92 molar.